Good day, everyone. My name is Rebecca Lilly with the International Association for Energy Economics. It gives me great pleasure to welcome you to today's webinar entitled Energy Efficiency and Energy Governance, a Stochastic Frontier Analysis Approach. We're grateful to our speaker, Josue Barrera-Santana, for today's timely discussion. First, a little bit about the International Association for Energy Economics. We are the largest association specializing in the field of energy economics and provide a forum for the exchange of ideas, experience, and issues among professionals interested in the field. The organization produces 2 professional journals, a newsletter, and holds conferences and virtual presentations, along with a host of other products and services you can find at our website at iaee.org. If you're not already a member of the association, we welcome you to join. A few housekeeping matters in regards to today's webinar before I hand things over to our speaker. First, this webinar is being recorded for those that cannot participate in today's live event. If you have questions for our speaker, please click the Q&A button at the bottom of the Zoom window and type your question. We've allocated time at the end of the webinar to read and answer them. And now I'd like to introduce you to our speaker, Josue Barrera-Santana. He's an industrial engineer at the Canary Islands Institute of Technology, where he works in several fields related to energy economics. Josue, over to you.
Thank you, Rebecca. It's my pleasure to be here today. As Rebecca said, my name is Josue Barrera-Santana. I come from the Canary Islands Institute of Technology. Although the work that I'm going to present today was developed also with the University of La Laguna, also in Spain, the Canary Islands. Well, the work for today is entitled Energy Efficiency and Energy Governance, in which we develop a stochastic frontier analysis in order to assess the role of energy governance on energy efficiency levels in a panel of countries. Here you can see an overview of the presentation. First, we will go through a brief introduction in order to understand why we developed this work. After that, I will show you an index construction for energy efficiency governance, because in the introduction we will see that there is no suitable indicators to assess energy matters like the relationship between energy governance, energy efficiency, energy consumption, or GDP growth, for instance. So there is an important need to construct an indicator like this. Once we have understood how the indicator is built, we will go through the stochastic frontier approach in order to measure the impact of energy governance on energy efficiency levels. And finally, we will have some concluding remarks. Okay, so first, I think it's clear as day that energy is at the center of the policy agenda for every country, or almost every country in the world, and also for a set of countries like the European Union, for instance. Reasons behind this, well, we have a lot of them. For instance, regarding electricity generation, well, 20% of global CO2 emissions stem from that generation. So another example, we have the year 2022 like another example. For instance, in this year we saw how the prices of the CO2 ton metric was from around 30 euros the ton metric in January 2021 up to more than 80 euros in July 2022. So we saw an increase in CO2 prices higher than 150%. On the other hand, we also saw the same year that the natural gas spot price went from around $2-3 the million British thermal units up to more than $7-8 the same unit. So it was an increase around 184%. So of course, these two facts, the electricity generation and some many other issues that are related to the energy field, has important economic and energy consequences. So we need to accurately estimate the impact of these facts, the impact of the energy sector on the economy, and vice versa, of course. So, well, it seems to be easy to do, but what's the problem to this point? Well, this is where we identify our first gap, and that is the lack of suitable indicators to assess the relationship between energy consumption, air efficiency, and GDP. As we will see a few minutes later, there are many works that try to use general approaches, general indicators in order to assess questions like this, but this is not the most appropriate approach. Okay. In this vein, in the relationship between energy consumption, GDP, energy efficiency is an essential driving factor for the relationship of all these variables. So this is where we identify a second gap, that is, there is still a lack of consensus on how to measure energy efficiency and overall how to identify its impact on energy consumption. So, well, the first gap, the need for an indicator suitable for these matters, is addressed by constructing an energy governance indicator, because as many works in the literature and many reports also from the International Energy Agency, from the World Energy Council and so on, demonstrate that energy governance has a really strong impact on energy consumption level and also on energy efficiency, of course. In fact, in a previous work, we demonstrate that our energy governance indicator is strongly related to energy efficiency. In fact, we found that the higher the energy governance, the higher the reduction in energy consumption growth. In other words, a country with a high performance of energy governance could achieve a lower energy consumption. So therefore, in this work, we try to assess the direct impact of energy governance on energy efficiency levels instead of using those channels like the GDP growth, the energy growth, as we did in the previous work. So here is how we constructed the index. Okay. As I said before, many works in the literature and many reports has demonstrated that governance is one of the most important drivers of energy consumption and thus of energy efficiency performance. However, all of these works assess this relationship between energy and GDP and so on by using general indicators, or to be more accurate, by using general governance indicators like the World Governance Index from the World Bank or the Policy for Project, among others. So unfortunately, the International Energy Agency, in its report from 2010, and some other works, as I said before, the World Energy Council in 2013, or some authors like Pereira and Pereira da Silva in 2017, have clearly stated that there exist significant differences between general governance and energy governance. So this fact would suggest is that general governance indicators should be avoided in the energy field when we are trying to assess these kind of matters. So the problem is that there was no available energy governance indicator up to date. So this is why we come up with our indicator. So energy governance, in order to construct our indicator, we closely follow the International Energy Report and the recommendations of this agency. The International Energy Agency defines energy governance as the combination of the institutional and coordination arrangements needed to scale up energy efficiency, but also added to the legislative frameworks and funding mechanisms which works to support the implementation of energy efficiency strategies, policies, and programs. So, in other words, this is the structure that the International Energy Agency provides for energy efficiency governance, or for energy governance. It's an structure which is based on three main areas: enabling frameworks, institutional arrangements, and coordination mechanisms. Every area is related to a different part of energy governance. For instance, enabling frameworks is more related to legal aspects like the development of laws and decrees, strategies and action plans, or the availability of funding mechanisms, for instance. Institutional arrangements, the second area, is more related to practical or pragmatic instruments like the idea of implementing energy agencies, conducting research on resourcing requirements, the role of energy providers, the role also of stakeholders, how public and private sectors cooperate in order to develop projects or measures and policies, and also international assistance. And finally, in the third area, we have like coordination issues like governmental coordination, the imposition of numerical goals, which is known as targets, and also evaluation mechanisms and procedures. So unfortunately, our index, although it draws on this structure, cannot assess all these indicators in every area because we don't have information enough for that. So our index will be based only in 8 indicators, taking 2 indicators in the first area, 4 indicators in the second area, and 2 indicators also in the third area. So it's important to understand, which is a very common question. Our index only provides one single score for every country in the whole period 2015. So we have 16 years from 2000 to 2015, and for the index 32 countries, although in the stochastic frontier approach we will use only 29. And for all that countries and all that period, we have only one single score of the index for every country. So we will have, in this case, 29 scores. So the construction of the index started with a data collection procedure. We used the International Energy Agency database, which had that time more than 1,800 entries. Every entry is like a register, like a qualitative and descriptive information, which is related with a single policy or a single law or a single strategy or a single measure and so on. So we, in these 1,800 entries, we have the information for our 8 indicators and 32 OECD countries. So after that, we have to filter the information. We decided to use only measures that were enforced between 2000 and 2015, and for the 32 OECD countries, as I said before, we constructed the index for 32 countries, but we use only 29 in the stochastic frontier approach. And after filtering the information, we have to classify. Classify means only that we need to know to which area of energy governance and specifically to which indicator this information is related. So after the classification, we have to score the countries. In order to score, as I said before, we have to score with one single score for every country for the whole period for every indicator, and after that, we will try to aggregate these indicators to construct sub-indices and a final index. So we started scoring every indicator, the 8 indicators that I mentioned before, with relative scores, which means that if a country has a point of 1, it doesn't mean that the country has a performance of 1, but that the country studied has a performance of 1 compared to the rest of the countries in the sample. So we chose, according to the literature, following the works of Norris, as you can see on the right, on the right corner here, the works of Norris, the OECD, and also from Raquel and Giselkis. We chose a score from 0 to 4, where 4 is the highest score, and we try to minimize subjectivity in the scoring procedure by using strict evaluation criteria, which we try to apply to all the countries in the sample. So after that, we aggregate the scores of every indicator using the average to obtain one subindex for every area of energy governance, and after that we aggregate again the 3 subindices in order to obtain one overall index. So this is an example of the procedure for the case of Spain. We have the score of every indicator on the left, laws and decree 3.2, strategies and action plan 4, and so on. So we calculate the average for every color. So we obtain 3 subindices: enabling framework, which would be 3.6, institutional arrangements, which would be 2, and coordination mechanism, which would be 3.5. And after that, we calculate again the average, and we obtain the overall energy efficiency governance index. So this is an example of the database. This database has been updated, but this is the one that we use. We download the data around 2018, I think it was the last time. So it was the appearance of the database for that year. For instance, this is the case of the United States. You can see here the US Climate Action Plan. If we click on that plan, we had a lot of information, and we have also a link in which we could read directly the measure or the policy. So after that, we have to apply the strict criteria following double analysis. For instance, in this case, for the indicator strategies and action plans, we ask these questions like, are strategies and action plans enough? Are the costs of the plans estimated and the target set for strategies and action plans? And well, we have different scores according to the results. These scores are not the same for all the indicators. I mean, the minimum score is always 0 and the maximum is 4, but the intermediate scores maybe 1, 2, 3, or maybe 0, 2, 4, and so on, according to the information available for every indicator. But of course, we use the same criteria for all the countries. So as a result, in this case, for instance, USA had 3 points because we found or we identified 19 studies and action plans with cost or target setting 11 of them. But in the case of New Zealand, we had a score of 2 points because we only identified 7 studies and action plans with cost and target setting 4 of them. So these are the results of the index. As we can see, there is a great variability from countries, high performance countries like Germany, Denmark, or France on the left, and some others which worse performance like Chile, Slovenia, or Estonia. If we look into the different areas, I mean the different colors like enabling frameworks, institutional arrangements, and coordination mechanisms, we also identified a great variability along the sample of countries. This is desirable characteristics because we want to identify or to have this variation from country to country in order to get a rich sample. So we have interesting cases, for instance, Switzerland or Norway, which in which the performance of energy governance is much worse than we could expect initially, and others like Spain, in which perhaps energy governance could be higher than expected. When we look these results in detail, we found that these results are related to, for instance, the state of development of the legal framework, the state of some other measures like the role that energy agencies perform in every country, and so on. So what I want to say is that these results are quite coherent with the information that we have. So here there are 2 important illustrations. I have been talking about energy governance, but I said that at the beginning that energy governance should not be misunderstood, should not be used. I mean that general governance should not be used instead of energy governance. And here is one of the reasons. For instance, on the left corner, you can see the relationship between energy governance and GDP, and that is economic growth, in other words. And on the right corner, you can see the relationship between energy governance and general governance. As you see, the correlation coefficients are higher when we look into the relationship between energy efficiency and economic growth, which means that energy governance is even more related to economic growth than to general governance. So that's why we have to say that they are measuring different things, and we cannot use general governance indicator for energy applications in general words. So well, after that, we can go directly to the application of the index into a stochastic frontier approach to measure the energy efficiency levels. Well, the main aim of this application is to assess the impact of energy governance, of course, on the energy efficiency level of our sample of 29 OECD countries in the period 2000 and 2015. Well, we use a stochastic frontier approach. I won't go very deep into the details of the methodology because it's a methodology commonly used in the literature when we are trying to estimate efficiency levels. But I would like to say that the stochastic frontier is a framework that runs on the microeconomic theory. Given a set of microeconomic data, a panel of countries, the stochastic frontier estimates the optimal combination of inputs to provide a specific level of output. In other words, in this field of energy consumption, what the stochastic frontier approach does is to estimate the optimal level of input to get a given level of energy consumption. So The frontier provides an optimal level, and we can identify the situation of every country in the panel according to that optimal level. The difference between the optimal level and every given country situation is what we call inefficiency. So this is our measure of energy efficiency. Why using the Stochastic Frontier Analysis instead of other well-known indicators like energy intensity? Well, for instance, energy intensity is only the relationship between thermodynamic unit and economic unit. In that case, it's energy consumption unit and economic growth unit. And therefore, changes in energy intensity may have nothing to do with changes in energy efficiency. That, for instance, when the economy of a country shifts to a less energy intensive sector, it could be understood as energy efficiency improvement, but it's not really an energy efficiency improvement. It's only a change in the economic structure of the country. So some other theories try to support the use of this indicator, energy intensity indicator. For instance, the index decomposition analysis is often used in order to separate these structural shifts in the economy from improvement in the use of energy. However, even when we use this index decomposition analysis, we find many drawbacks that are still to be solved. For instance, this decomposition is very dependent on data availability. It may be influenced by external factors like weather, for instance, if this is a very hot or very cold year. And also, the index decomposition analysis is able to capture structural changes within the national economy, we could say, but it's not able to assess that structural shifts in within every energy sector. Perhaps the methodology could allow us to assess that changes, but usually there are no available data on these levels. So this is why we finally chose the use of a stochastic frontier approach. This would be the basic equation. On the left, we can see EIT, which is energy consumption of country I in GRT. And we have, well, the energy prices, which are called here PIT, a set of explanatory variables, and two error terms, which are VIT and UIT. We will talk more about them in a few seconds. So in our set of explanatory variables, following works in the literature like Filippini and Han 2011, Filippini et al. 2014, many others, we use variables like the GDP, which is YIT, population, urbanization rate, the area of the country I, climate damage like oceanic on cold, the share of different sectors from the economy like industrial sector or services sector, and DT, which is a time trend in order to capture technological progress along the years, for example. So the most important terms in a stochastic frontier approach are VIT and UIT. VIT is the normal random error term that we could find in any econometric estimation, but UIT is a very special error which provides us with information regarding the inefficiency level of a country. So UIT is that distance that informs us about the situation of a country regarding the optimal energy efficiency level. It can be calculated as you can see here, but the most important part is that this inefficiency term, this error UIT, can also be regressed over variables like theta IT, getting one random error term. This is the most important part because here is where we can introduce our energy efficiency governance index to assess its impact on the level of a panel of countries. So our contribution in this work is to introduce the index in this approach, as I said before, and using the most up-to-date stochastic frontier models. Well, in order to assess the robustness of our work, we try to use as many approaches as possible. So some of them allow exogeneity to explain efficiency, the UIT term, and some others do not. So what we do is to compare approaches with and without our energy efficiency governance index as explanatory variable for energy efficiency. We use different models from Batesi Coeli, from 1995 up to the pairwise difference estimator from 2018 proposed by the authors Bellotti and Ilari. So the difference between these models are, well, the most recent models try to improve the efficiency of the calculation, try to reduce the size of the variance in the calculations, and so on. So, well, our best or preferred estimation would be the one provided by the pairwise difference estimator model, because it's the most recent and perhaps the most adjusted. So our main results suggest that energy governance has a direct and negative effect on energy efficiency. In other words, the higher the energy governance quality, the higher the energy efficiency. In terms of stability, accuracy, and efficiency, as I said, the pairwise difference estimator is our preferred approach because it provides the most accurate estimates and also the most computationally efficient estimates. In terms of the PDE results, increasing the energy governance index score by around 10% may increase energy efficiency by around 9%. We have to take into account that our results are relative results. I mean, these results are only correct if we take into account that we are comparing a sample of countries. So we couldn't estimate the specific level of efficiency in a country individually if we do not take into account the rest of the panel. So if we look into an indicator-based analysis, we find that evaluation and targets are essential to fulfill energy policy goals, accounting negative and significant effects on energy efficiency, which means the higher the score of these indicators, the higher the level of energy efficiency of a given country. Only to remember, on the right corner, you can see the structure of energy governance. We are talking about these two indicators that are included here in the theory area. So for instance, the elasticity of estimated for the targets indicator is close to 1%, which means that taking into account the example of Estonia, for instance, the inclusion of additional targets, for example, reducing emissions, penetration of renewables, or building codes, may raise the score of the targets indicator by 25%, and efficiency may increase up to 25%. Looking at the evaluation indicator, its elasticity is close to 0.66, which means that increasing evaluation mechanisms to over 50% of the promoted plants in Canada, for instance, could improve the score by 25%, and efficiency may increase up to 16.5%. So the key point of all this explanation is that energy governance has to be assessed in a country-specific base, because it's not the same to improve the quality of energy governance in a country than in another, because the structure of energy governance may be very different. So other variables in our analysis, like the GDP, energy prices, or the area of the countries, performs with the expected results. And the lambda estimate. Lambda is the parameter commonly used in stochastic frontier analysis in order to assess the accuracy of the results. Well, in our case, provides reasonable size and significance, which is as expected. This is the graphical output. As you can see, we have high performance countries like Germany, France, and Canada again, and perhaps the worst countries, maybe Greece, Slovakia, or Estonia. These results are strongly related with the score of the energy efficiency governance index, as we expected. I mean, the energy governance index is, according to these results, a very important variable in order to estimate the energy efficiency of a given country. So here we can see the results just in tables in order to go a little bit deeper into the coefficients and significance. This is the road that we are looking at just to make sure that energy governance has an important impact on energy efficiency level. As we can see in all our models, the sign that we find is a negative sign, which is the higher the energy governance quality, the lower the energy inefficiency, and all of them are very, very significant, which is as we expected also. This is the result that I mentioned before. And this is the results if we look into the individual indicators, one by one until 8 indicators, and a final column 9 in which we include all the indicators. We did this first individually and finally all the indicators together, just to make sure that our results were correct, because when you add many variables in a stochastic frontier approach, you sometimes can start to find some troubles in the estimation process. So here is where we can see that evaluation and targets are key indicators with negative signs and with high significance. But we also found an interesting result. For instance, it says that implementing energy agencies may have a positive effect on inefficiency. To this fact, to this result, we have to add that there are many kind of energy agencies. We found national energy agencies, regional energy agencies, and so on. All of them play a different role. Sometimes they are supported by legal frameworks, but sometimes they are not. Sometimes they account for important economic funding. Other times they don't have that funding, and so on. So perhaps this is the reason why we found this positive sign. In addition, the existence of any area agency doesn't mean that this agency is developing properly or at least successfully his work. So, well, just to conclude here, we have 4 important points. We have that energy governance requires a definition of national interest. As I said before, it's country-specific. We cannot provide general rules for a good energy governance because it would be a huge mistake. Energy governance accounts a strong impact on energy efficiency level between 9 and 27%. Every 10% increases in the energy efficiency governance score according to the different models. Targets and evaluations are among the most important policies in order to improve energy efficiency, and these results are supported by many different models and throughout robustness assessment. So for the time, that's all. So if you have any question. Well, a common question that we always find at this point is, for instance, why we didn't construct a time varying energy governance index. Well, the answer to this is that the energy governance index is the procedure of constructing the energy governance index is quite difficult. It took like 3 to 5 years. We had to assess a lot of energy efficiency measures. So it would be really difficult to construct a time varying index. And in addition, many of the policies that we found are sometimes superseded by other ones. Other times they are proposed for time horizons very large, like 10 or 20 years. So it's quite difficult to identify a real pattern in order to calculate a time varying index. Well, Rebecca, I'm not sure if we will have more questions.
Well, IAEE would like to thank Josue Barrera-Santana for an outstanding webinar. The webinar will be available on IAEE's website for future download. If you're not already a member of IAEE, we encourage you to join by visiting IAEE.org. We thank you for attending, and I officially close this webinar.